Okay, so we've already taken a look at solving quadratic equations, but now there is another way to solve them. You've probably seen this before as well, the quadratic formula. So basically the quadratic formula is if you have an equation similar that looks like ax squared plus bx plus c, you can find the roots of that quadratic equation by plugging it into this formula right here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's a formula you'll really need to have in your notes, and you'll have to have memorized for the test. Okay, so a proof, we're going to write out a proof to prove that this works, this is true. So the first thing we're going to do is we're going to start with our ax squared plus bx plus c, and we're going to divide that a by everything. So divide by a everywhere. Oh, and we're going to put equals 0 over here. Okay, so we are going to end up with x squared plus b over ax. And then I'm actually also going to move this c over a to the other side. I'm going to get negative c over a. And then the next thing we're going to do is we're going to do completing the square, which we know how to do because we did it in the last problem. So to complete the square, we need b over, so since b is actually b over a, it's going to be b over a over 2, so b over 2a squared. Okay, so that is what we need to add to both sides. So x squared plus b over ax plus b over 2a squared equals negative c over a plus b over 2a squared. So then we can simplify this side using the completing the square formula that we know from last time. We can make this look like x plus b over 2a squared on the outside. And then this side, when you multiply it and add it together, it becomes negative 4ac plus b squared over 4a squared. Okay, and then you're just going to take the square root of both sides to get rid of this squared here. You're going to take, let me do it in a different color. So you're going to take the square root of both sides, so that goes away, and you get x plus b over 2a equals, and then this answer is going to be positive or negative. And if you simplify that, the square root at the top and then the square root at the bottom, it actually comes out the square root at the top stays, if you flip it, it just becomes square root of b squared minus 4ac. And you take the square root at the top, and then the square root at the bottom is just the square root of 4 and the square root of a squared, which is 2a. And then we need to add this over there, okay? So that becomes x equals, and you're basically just adding b over 2a to this side, which has 2a on the bottom, so you can make it all one big fraction. I mean, you're subtracting it, right? Subtract b over 2a, and you get, on this side, you get negative b plus or minus that, and then 2a on the bottom since they both had that common denominator. So that's the proof for how to get our equation up here. So example 7 says find the real solutions. We're going to have to use the quadratic equation to find these. So the first one, a, is 3x squared minus 5x minus 1 equals 0. Okay, if it is not set up with 0 on this side, you need to make sure it gets that way. So then we can start writing out what we know. We know that a is 3, b is negative 5, and c is negative 1. So now we can plug that in to our quadratic equation. So just a reminder that the quadratic equation is negative b plus or minus the square root of 4ac no, plus or minus the square root of b squared minus 4ac all over 2a, and so now you just plug everything in, okay? So x equals negative 5 is 5, plus or minus the square root of negative 5 squared, and that's going to become a positive, but you have to show the negative there, minus 4ac, and that negative 4 times 3 times negative 1 is going to become a positive, all over 2 times 3. Okay, so you end up with 5 plus or minus the square root of, this is 25, and this is 4 times 3 is 12, so plus 12, all over 6. Okay, and so the most simplified way to write this is just 5 plus or minus the square root of 37 over 6, and you can leave it like that. There's two answers here. Remember, this is a quadratic formula, so there's two answers here. Quadratic means x squared is in the equation and that there's going to be two answers. This one is going to be 5 plus square root of 37 over 6 or 5 minus 37, square root of 37 over 6. Okay, and then approximation is, you can approximate if you would like to. So, or if it asks for you to approximate, you need to write it like this. 5 plus square root of 37 over 6. Plug that into your calculator and you write approximately 1.85, depending on how much it wants you to approximate to, or x, the other option is minus square root of 37, and your other answer is approximately negative 0.18. So make sure you can plug those into your calculator and get the same answers. Okay. B, 4x squared plus 12x plus 9. We're going to do it again. We'll do it a little faster this time. So we're going to write out A equals 4, B equals 12, C equals 9. Okay, so we can just plug this into our same formula over there. X equals negative 12 plus or minus the square root of 12 squared minus 4 times 9. Make sure to extend your square root over all of that. And then on the bottom is 2 times 4. Okay, you can do some of this simplification on your own, but the answer here becomes negative 12 plus or minus the square root of 0. Okay, so you should be able to get that that's 0 under the square root, and it gets 0 left there over 8. So actually, this one's only going to have one answer, and that answer is going to be, because x plus or minus, negative 12 plus or minus 0 is going to be just negative 12. So that answer is negative 12 over 8, which is the same as negative 3 over 2. Okay, so that's our one answer here. And then over here, this was our answer, or these two were the answer as well. Okay. And then C, using the quadratic formula, one more example. X squared plus 2x plus 2 equals 0. So again, I'm going to write out my A. A is 1, B is 2, C is 2. So x equals b squared, or negative b, negative 2 plus or minus the square root of 2 squared minus 4 AC over 2a. So pause the video, try to solve that yourself. You should end up with negative 2 plus or minus the square root of negative 4 under here. Okay, and then all over 2. And then this one can actually be simplified. So this is an example of something you have to simplify. So you actually need to pull out the square root of 4, which becomes a 2 on the outside, So actually, we need to rewrite this as -2 plus or minus. If you pull out the 2, okay, that comes on the outside. The only thing left under there is that -1. We're not going to do i's right now. You look at that and you think that's a complex number, okay, but we're going to leave it like that, all over 2. And if there's a number that's in the bottom and in both spots, you can cancel it out, but only if it's in both terms on the top. So actually this becomes the same as -2/2 plus or minus 2 squared and -1 over 2, and that's why that cancels, okay? So x is -1 plus or minus the square root of -1. And then you can also, you cannot plug this one into your calculator. It'll give you an I value. It won't work. Okay, a new vocab word is the discriminant. The discriminant of a general quadratic equation, ax squared plus bx plus c equals 0, is discriminant equals b squared minus 4ac. Okay, so if that looks familiar to you, that's because it comes from this part under the square root of the quadratic formula, b squared minus 4ac. So basically, this discriminant can help us figure out how many solutions there are and what types of solutions they are, okay? So if you calculate discriminant and the discriminant is greater than 0, aka a positive number, then your equation has 2 real solutions. If you calculate discriminant and you get d equals 0, then the equation has exactly 1 real solution. And if you calculate the discriminant and you get d is less than 0, so discriminant is a negative number, then the equation has no real solutions. It actually has complex solutions, but we're not going to worry about those right now. Okay, so here is an example for today, the last example. Okay, so this example is use the discriminant to determine the number of real solutions. Okay, sorry about the lighting. All right, so what we're going to do is we're going to use that equation we just came up with how to find discriminant. So I'm just going to write a equals 1, b equals 4, and c equals -1. And then I'm going to use my discriminant equation. Discriminant equals b squared minus 4ac. Remember that. So for this one, it's going to be d equals 4 squared minus 4 times 1 times -1. So if you do all that math, you're going to get d of 20, which is greater than 0. Okay? So since d is greater than 0, your answer is going to, this equation is going to have 2 real solutions. Okay, b right here is another equation, so we're going to solve it in the same way. A equals 4, b equals -12, and c equals 9. So discriminant equals -12 squared minus 4 times a times c. So d, if you do that math in your calculator or just by hand, you should get 0. D equals 0, so if your discriminant is 0, the answer is exactly 1 real solution. Okay, that's the answer there. And then c, 1/3 x squared minus 2x plus 4. So that's going to be a equals 1/3, b equals -2, and c equals 4. So d equals -2 squared minus 4 times 1/3 times 4. So I'm going to get, if you do this by hand, so take a second, pause the video and do it, you're going to get -4/3 as your answer. Okay, and that is a negative answer, which means it's less than 0. So this equation up here, basically what you found out, it is going to have no real solutions. Okay, and that's how you use the discriminant to help you decide how many answers there are.